Yes, friends. On the board, I have written the difference between interference and diffraction of light. You know, interference is produced by superposition of wave fronts coming from two narrow sources of light. Two narrow sources of light which are monochromatic and coherent also. Monochromatic and coherent. While diffraction is the result of superposition of secondary wavelets coming from different points of same wavefront. Diffraction, as I have explained, the diffraction due to narrow slit, same wavefront, secondary wavelets. Every point on secondary wavelet behave like secondary source of light. So diffraction is result of the superposition of secondary wavelets coming from different points of same wavefront. Width of bright and dark fringes is the same, and the maximum minimum are never of same width in diffraction. The width keep on decreasing, maximum minimum both. Here all bright fringes are of same intensity. The intensity of maximum is never same, keep on decreasing. There is a large difference between maximum and intensity. And intensity at minima is usually zero in interference, and there is good contrast between maximum and minimum. The last point there, it may not be properly visible to you. There is a good contrast usually between maximum and minimum. Here the intensity at minima is never zero. Some light is seen in diffraction pattern at minimum, and there is poor contrast between maximum and minimum. So you please learn this. Actually, I have written just to save time of the video, and so that good message should go to you. And this is important point here. You please learn it. Now I come to next point here, which is very important. And you will, if you will be science student further in graduation, and you want to do academics in physics, then this point will always be there. Diffraction is caused due to wave nature of light. So here I want to discuss with you the limit of resolution. Limit of resolution and resolving power. Why there is a limit of resolution? What does it mean? Ability of every optical instrument to form two distinct separate images of two-point objects which are very closely placed is called resolving power. I will write it later on. We are able to see the distance between atoms or molecules of solids while it is distance between the atoms of metals is of fraction of angstrom, but we are not able to see. But distance there. Why it is so? So, due to wave nature of light, light produces diffraction. Diffraction is caused by light because of wave nature. Due to diffraction, the image of a point object formed by a lens is not sharp. This image, the image formed by image of point object is not sharp. The image of point object formed by a lens is a disc of angular diameter theta is equal to lambda by d, where d is the diameter of aperture of lens. In microscope, we use lenses of very small aperture. So theta becomes very large, and lambda wavelength of light. So, if two objects, point objects, are very close, actually I am explaining you on an average. Precisely diffraction meaning is explained other way also, and we are not aware of those facts. So I am telling it in very brief and on an average definition. If two point objects are very close, then the image formed of these points object formed by a lens may overlap each other as they are disk of diameter, their disks may overlap. Hence, the two may not be seen separately or distinctly. So who causes this problem? wave nature of light. Because of wave nature, so due to wave nature of light, diffraction puts a limit to resolution. This is a simple idea कि भाई these are two point object here, image formed by lens like this, and they may appear as one. So it is diffraction, है ना, which causes the limit to resolution. Now, what is resolving power? तो resolving power डेफिनेशन याद होनी चाहिए, पता होना चाहिए. Resolving power. Resolve means make separate. The ability of every ability of an optical instrument may be defined as the ability, or you can say power also, or power to form separate or distinct images of two objects placed very closely. सिंपल बात है ये, है भाई. The simple matter here. Now, then how to measure the resolving power of microscope? Very important topic. Actually, the deletion of topics in the syllabus is causing a severe problem. Dear friend, try to learn the basic things. Just now, some students were there with me. In trigonometry, questions are deleted, and that's why students are not able to learn sin 30, cos 30. If there is sufficient number of questions to be done, then it is learned itself. So, resolving power of microscope. I have made you clear. The purpose of microscope is to magnify as well as to resolve the smallest distance which can be resolved by microscope is given by d equal to 1.22 lambda upon 2n sin theta, where wavelength of light used. And refractive index of medium between object and objective lens. Objective lens of microscope, theta, half of the cone angle subtended by object on objective lens. यानी कैसे भाई? How? This theta, it is the object here, it is the objective lens, this is the cone angle, so this theta, this is here lens, objective lens, this is point object O, so this theta half angle. So d smallest, smaller the distance d, larger the resolving power. So reciprocal of d, in fact, reciprocal of d is the measure of resolving power. Now, n sin theta, 2n sin n index. You might have seen library in biodiag. When you see slide, we place some glycerine on the slide because the index of glycerine is more than here, so d get decreased. Larger than theta, but there is a limit of this also. The wavelength, you know, wavelength of light vary from 4,000 angstrom to 6,000 angstrom, 7,000. So average wavelength can be taken as 6,000 angstrom. So large value of wavelength causes the large value or small resolving power. So to decrease d, what we can do? We can increase n and decrease wavelength also. How can we decrease wavelength? Light though has this range 6,000, 4,000 to 7,000 angstrom. You might have heard about electron microscope. So electron microscope use electron beam in place of light, and that beam of light is converged or diverged using magnetic field, electric field. De Broglie wavelength of electron, you might have learned, is 12.2 upon under root V. And so V is the voltage through which electrons are accelerating. V potential difference, you know. If it is 100, then wavelength 1.2 only angstrom. And if it is 10,000, 8.12. So that way, using electron beam in place of light, we can increase the resolving power up to 20,000 times. So there was a question in the board, that the resolving power of electron microscope is more than the optical instrument or optical microscope, or less than this or more than this. So teachers were surprised Actually, this electron microscope is one practical application of de Broglie wave. So please note it. We use electron beam. Electron microscope is that in which we use electron beam in place of light. Students will say okay, we can see electron. No. Now in case of telescope. The smallest distance, the smallest angle which can be resolved by telescope is given by delta theta I must say is equal to 1.22 lambda upon d. D is the diameter of the aperture of objective lens. So larger the aperture of objective lens, smaller the theta, and hence higher the resolving power. Any reciprocal of delta theta is the major resolving power. Though there are different criteria also, but here we are not aware of many facts. So I explain you this in general. On an average, what is resolving power? I think in syllabus it has been deleted, but questions are there in competitive exam and anywhere else also. I hope you will enjoy this chapter. I will be telling you some numericals in coming videos.